All right, welcome to The Explainer. Today we're going to talk about a protocol that was like the backbone of the early internet, and its ideas still super important. We're talking about the point-to-point protocol, or, you guessed it, PPP.
So let's start with a really basic problem. Picture this. You've got two routers, maybe one in New York and one in LA, and they need to talk to each other over a dedicated line. The big question is, how do you actually make that happen reliably?
And that's the real kicker, right? It's not just about flinging data across a wire. It's really about a negotiation. I mean, both sides have to agree on everything. The language they'll use, how big the data packets can be, security stuff, you name it. If you don't have a solid set of rules, what you get is, well, just a total mess. You know, the first attempts to fix this, like a protocol called SLIP, they were just too simple. Think of it like this. Two people are trying to talk, but they can't be sure if the other person even heard them right. They have no idea if they're actually talking to who they think they're talking to, and they have to manually agree on every single rule before they even start. It was a start for sure, but for a network that was starting to grow, no way. It just wasn't going to cut it.
And that's where our hero comes in. Enter the point-to-point protocol. It was literally designed from the ground up to solve all those problems we just talked about.
So what is PPP at its heart? Well, think of it as a complete rulebook for any connection between exactly 2 points. It works at layer 2, the data link layer of the OSI model. And what that really means is its job is to manage that direct physical connection. But here's the really crucial part. It wasn't just built for one kind of data. No, it was designed to handle a bunch of different network languages. And back then, that was a massive leap forward.
So how does PPP pull all this off? Well, here's the secret. It's not really one single thing. It's more like a super skilled team of 3 specialists all working together. So let's meet the team, shall we?
First up, we have our package handler. This part of the team uses something called HDLC-like framing. Its one and only job is to take the data, doesn't matter what it is, and package it up nice and neat for the journey. It's exactly like putting a letter into an envelope before you pop it in the mail.
Okay, so this is the envelope we were just talking about. The flag is just a marker for the start and end of the package. The address and control fields, they're always the same because, hey, there's only one place it can go. Then you've got the protocol field, which is like a label saying, hey, this is what's inside, followed by the actual data. And last but not least, the frame check sequence, or FCS. Think of that as the wax seal on the envelope, making sure nothing got messed up along the way.
All right, team member number 2 is the Link Control Protocol, or LCP. If the first guy was the mailroom clerk, LCP is the diplomat, the negotiator. Its whole job is to set up the rules, manage the conversation, and then, when it's all done, handle the goodbyes and tear down the connection.
Yeah, LCP literally manages the entire life of the connection. It kicks things off by negotiating the terms, asking questions like, okay, what's the biggest frame size we can both handle? Or, are we going to need to show some ID here, authentication? Then, once the link is live, it kind of pokes the other side every now and then, sending these little, hey, you still there messages, just to make sure things are running smoothly. And when the conversation's over, LCP is the one who makes sure it ends cleanly, no loose ends.
And our final specialist on the team, well, it's not just one. It's a whole family of them called Network Control Protocols, or NCPs. So while LCP is the general manager for the link itself, each NCP is a specialist, an expert in a specific network language. You had one for IP, one for IPX, one for AppleTalk. Each had its own expert.
Now, the one we'd see most often, by far, is the IP Control Protocol, or IPCP. And this is the one that actually gets you on the internet. It's the one that negotiates your IP address, tells your computer where to find DNS servers, and it can even set up things like data compression to make slow connections feel a bit zippier. I mean, think about it. Without IPCP, you'd have a connection, sure, but your computer would have no clue how to actually talk to the rest of the internet.
Okay, so we've met our dream team. Now let's watch them in action and see how they actually build a connection from start to finish. It's a really logical, step-by-step dance.
Yeah, you can really think of this as a carefully choreographed dance. So it all starts with the link being totally dead. Nothing's happening. Then, once a physical connection is made, our diplomat, LCP, steps in to negotiate the basic rules. Then there's an optional security check, like a bouncer at the door. After that, the network specialists, the NCPs, come in and set up the IP address and all that good stuff. And only then, after all that's done, does the link finally open up so data can start flowing. And at the very end, LCP comes back to close things down nice and tidy.
Okay, so now that we've got a handle on how PPP works, let's zoom out a bit. Let's talk about some real-world stuff, like security, and how PPP compares to some of the other players out there.
When it comes to security, PPP has two main options. The first is called PAP. It's simple, but it's also incredibly insecure. Why? Because it sends your username and password in plain text. Anyone listening could just grab it. The much better option is CHAP. It uses this really clever three-way handshake. The server sends a random challenge, and the client uses the password to create an encrypted response. And here's the key. The actual password never gets sent across the network. Big difference.
And if you put PPP side by side with that older protocol, SLIP, oh man, it's not even a fair fight. PPP can handle all sorts of protocols. It checks for errors, it has real security, and it configures itself. SLIP, it did none of that. It's not just an upgrade. It's like going from a bicycle to a car.
Here's another really important comparison: PPP versus something proprietary like Cisco's own version of HDLC. The key difference here is massive. PPP is an open standard. That means a Juniper router can talk to a Linksys router, can talk to a Netgear router. You get the idea. Any vendor can use it. But with something like Cisco HDLC, you're stuck in their world. You have to use Cisco on both ends. And that right there, that ability for anyone to work with anyone, that's why open standards like PPP are so incredibly powerful.
So look, we probably aren't firing up our dial-up modems much these days, but the ghost of PPP is absolutely everywhere. And that leaves us with a final thought, right? These core ideas that PPP really championed, things like negotiating the rules of the road, carefully packaging up data for its journey, and proving who you are before you talk. Those principles didn't just disappear. They are quite literally the fundamental building blocks for how our modern networks, our Wi-Fi, our fiber, everything, build trust and talk to each other every single second of every single day.